So this leads us to step 10, which is very closely related to step 9. Now we said for example 1, dealing with the water filling up into our fish tank, we didn't have to do step 9 because it's already in terms of the HGT, which is what we're trying to solve for. So if you don't have to do step 9, you don't have to do step 10 either, which is replace remaining variables with their values in the derivative equation. So we're not going to spend too much time on example 1 just because we already have it in terms of the variable we're trying to solve for. Now, however, for example 2, which has to do with the ladder sliding away from the wall, we did have to implement step 9. We had to solve for x, the x right here, and we had to solve for the h. We found x to be 2.3 and h to be the square root of 19.71. So for step 10, we will just simply plug those values in for x and h, and if you notice now, we only have one variable left, which is the HGT, which is what we're trying to solve for, the rate in which the top of the ladder is falling towards the ground. And so step 10 is really easy. You're just replacing the remaining variables with their values to get rid of them so you can solve for what you're ultimately trying to solve for. Again, in this case, it's the rate of the velocity at the top of the ladder at time t equals 1, which we called dHdt. So you can see why this is important, right? Because you want to get it down to that one variable we're trying to solve for. Okay, for example 3, again, we have the water filling into a conical tank. And this one's also easy because we figured out that step 8, once we plug everything in, we only have what we're trying to solve for, which is dHdt, the rate in which the water is rising in this conical tank. So that means we don't have to do step 9 because there are no remaining variables, just the one we're trying to solve for, which means we don't have to do step 10 either, which is replace the remaining variables with their values. We can move on from example 3 and go to example 4, our favorite example of the coffee falling out of the cone into the coffee pot. Now for this one, we did have to figure out the second volume rate, the rate of the in which the volume of coffee is entering the pot, which we said is the same as what it's coming out. We figured out what's going in at 25 pi over 4 cubic inches per minute. So we will implement step 10. Since we figured this out to be 25 pi over 4 cubic inches per minute, we are just going to simply replace it with 25 pi over 4 for step 10. Replace remaining variables with their values, if necessary. In this case, it was necessary. And guess what? Now we just have one variable left, dh2 dt, which represents the rate of change of the height of the coffee pot, which is what we were trying to solve for in our original question. How fast is the level of coffee in the pot rising? So that's it for step 10. We're basically there now. All we have to do is just do some algebra for each of these and we'll be done. Okay? So you can see why this is called related rates. I keep mentioning that just because, you know, the way the world works and the way things work in the real world all has to do a lot of times with rates and speed and things like that. I used to live in South Florida where they have these canals letting water, when the water builds up in those canals and it starts to flood, they're able to release that water based on the rate in which it's raining. You know, how fast, how many inches per hour they're getting and stuff like that. And those are kinds of things where related rates applies to the real world when you deal with engineering problems that affect many people. So we're almost there. We're just going to do the next step 11 for the next video, which is to solve for the variable. And then after that, we're going to, come up with a sentence that makes sense to solve these related rates problems, which are word problems. Okay, so that's it for step 10, replacing the variables. Like I said, we're almost done solving each of these, and that'll be it for related rates. If you have any other questions about this step, let me know.